The lesson today is over polynomials. The objectives are to identify, evaluate, add, and subtract polynomials, and then also to classify and graph polynomials. So you'll need to use your calculator for a lot of those. Here are some examples of monomials. You have to know what these are called or else this isn't going to work. A lot of this is from the beginning of Algebra 1, but you have to know this to move on. 2x squared. That's a monomial because it has one term. There is a 2 and there is an x squared, but they are multiplied together. So that means they're just one term, 2x squared. Y to the third is a monomial. Yes, you could write that as 3y's multiplied together, but it's still just one term. That's a monomial. 3x squared, y to the fourth. That's a monomial. 3 times x squared times y to the fourth. You have three different terms multiplied together to create just one term. Negative half a to the third bc squared. That is still a monomial because it is one term. Several different items multiplied together. Here are some examples of polynomials. Poly means more than one or many. A polynomial can be a monomial. So you can include those in there. Monomials can only be something like this, but a polynomial can be this and anything else that is added or subtracted in there. So 3x to the fourth is a monomial and a polynomial. This one has two terms, 2z to the 12th plus 9z to the third. You have two terms separated by a plus. That separates them. So this is a polynomial. 0.15 x to the 101st power. That's a monomial, but it's also a polynomial. 3t squared minus t to the third, polynomial. Only, cannot be a monomial because it has two terms separated by a subtraction. The following are not polynomials. 3 to the x power. If you're going to have something that's a variable in the exponent, we're not going to consider that polynomials. The absolute value of an expression, that's not going to be a polynomial. Eight over 5y squared. Variable on the bottom, exponent on the bottom. We're not going to consider that to be polynomial.
I need Mr. Biggs' 7th grade homeroom, and I need Mr. Shoup's homeroom.
A half square root of x. If you have square roots in there, we're not going to consider that to be polynomial. M to the 0.75 power minus n. Decimal exponent. Not going to consider that to be a polynomial expression. Now we have to identify the degree of a monomial. Here's how you identify the degree of a monomial. Identify the exponent on this. When it's just one term, you look at the exponent. So that would be the fourth degree. Now in this one, you have 12 with nothing written beside it. 12 is the same thing as 12 times x to the 0 power. That's an 8. That should be a 0. X to the 0 power. Anything to the 0 power is 1. So this does not change. 12. So 12 is still equal to 12x to the 0 power. Have a 0 degree. In this case, you have 4a squared b. You have two different variables. The exponents are the following. You have a 2 and a 1. You add them all together. So 2 plus 1 would be 3. Third degree. And then in this one, x to the third, y to the fourth, z to the first, add the exponents together. 3 plus 4 plus 1, that would be the 8th degree. Identify the degree of this and drop it off up here. Whenever it's one term, one variable, one exponent, the answer is going to be this. Should be 3. Remember that 7 is the same thing as 7 times x to the 0 power. Anything to the 0 power is 1, so it doesn't change the value of this. Answer should be 0. You have 2 plus 3. Answer should be 5. Your exponents are 6, 1, and 2. That would give you a total of 9. All right, classifying polynomials. Two examples. We'll focus in on the first one. Rewrite each polynomial in standard form. Then identify the leading coefficient, the degree, and the number of terms. Name the polynomial. So let's zoom in here on this one. You have 2x plus 4x to the third minus 1. Write the terms in descending order by degree. So the highest power of x in there is 4x to the third. And then the next one down is 2x to the first, and then you just have minus 1. So you've written it in descending powers of x. The leading coefficient. Coefficient is the number multiplied by a variable written to the left. The leading coefficient is 4. The degree of this polynomial. You do not calculate the degree of a polynomial the same as you do a monomial. Notice you have x to the third, and then you have 2x to the first. If you add those together, it's 4, which is not right. Monomial degrees are calculated differently than polynomial degrees. A question or a statement that I will hear later on is, you told us to add them all together. And that is technically true for monomials, but polynomials is different. It is the first exponent after you put them in descending powers of x, so that would be a 3. You have 3 terms in here. I've underlined each one of them. Terms are 3. Therefore, cubic trinomial. If you have 3 terms, tri is 3. So yes, it's a polynomial, but what specific type? It is a trinomial because it has 3 terms. Cubic comes from the third power. Here's example B. You have 7x to the third minus 11x plus x to the fifth minus 2. You have to write that in descending powers of x, putting them in order. So your highest power of x is 5. We have x to the fifth. The next one down, plus 7x to the third, minus 11x minus 2. The leading coefficient out here to the very far left is 1. The degree comes from the highest power of x. It is 5. You have 4 terms, all of which have been underlined in red. So now we have to name this polynomial. According to the leading exponent of 5, that makes it quintic. 4 is quartic. 3 is cubic. And of course 2 is square. And so forth and so on. So it's a quintic polynomial with 4 terms. Once you get past trinomial, you don't name it. You can call it by its degree, which is quintic, and just call it a polynomial. A quintic polynomial with 4 terms. First, we have to rewrite this. So if we rewrite this in descending powers of x, we would have a negative 2x squared plus 4x plus 2. The leading coefficient is a negative 2. The degree is 2. When you have a square, you should remember back from Algebra 1 that when we did things such as, and I'll write them here, x squared plus 6x plus 10 equals 0. We could have solved that by factoring, if possible, or we could have used a formula. What was the name of the formula? What was the name of this formula? Quadratic formula. So if you solve an equation with the quadratic formula, what's the name of the equation that you're solving? Quadratic equation, right. So the name of this would be a quadratic trinomial. Here's another one. Try this one. You have to rewrite this in descending powers of x. So it's x to the third minus 18x squared plus 2x and then minus 5. We have rewritten it. The leading coefficient is 1. The degree is 3. So this is a cubic polynomial with 4 terms. Add or subtract. Write your answer in standard form. So you're given 2 polynomials that you have to add together. And in this case, you have addition, which means there's no need to rewrite any signs in the second polynomial. So it's a matter of adding like terms. You can add vertically by once you put these in the proper order, such as 3x squared added with x squared. You can add those top to bottom like that. Or you can just go from here to there and get a 4x squared. There is only one cubic term in here, and that is 14x to the third. It's added with nothing, so it stays the same. You have x minus x. Those just cancel out. You have a 0x. And then, of course, there's a 7 and a 2. Those add together to get a 9. You do not write 0x in your final answer. So when you add those 2 terms together, you get 14x cubed plus 4x squared plus 9. That is your final answer. If you have to subtract polynomials, like I said before, the second polynomial would have to be rewritten, because when you subtract a quantity, which is what you have here, you distribute that minus sign, which now becomes multiplication by negative 1. Distribute it all the way through each term. So you end up with a negative 3x squared minus 2x minus 5. And once you do that, then you can add like terms. Once you distribute this, it then changes to
At
a...
this time, would Mr. Sayers's and Mr. Smith's Cat's homeroom teams please report to the gym for pictures?
Once you do the distribution by the -1 through the second set of parentheses, then you can change it to addition. You're just adding like terms. So in this case, you would have a -x squared plus a -3x squared. That's -4x squared. 1 plus 5 is 6. And then you just have a -2x, which you have nothing to add that with. So it just stays. This is your answer.